In this video, we explore the concept of modularity in programming. Modularization is a process of dividing a software system into smaller, independent, and reusable units called modules. Modules can be developed, tested, and maintained separately, and then integrated to form a complete system. Modularization has several benefits for software engineering, such as improving readability and understandability of the code, enhancing reusability and maintainability of the code, reducing complexity and coupling of the code, increasing cohesion and abstraction of the code, facilitating parallel development and testing of the code, enabling scalability and adaptability of the system. I already mentioned the need to avoid code duplication and to encourage code reuse instead. The video focuses on one of the tools that are at our disposal to facilitate modularization and code reuse, the function. In a previous video, we have seen how to create the output presented here. The proposed solution uses nested loops, the inner loop to draw a single square and the outer loop to draw 20 concentric squares. If you look closely to the code, you can see that the part highlighted in the yellow box is what draws a square of a given size at a given position. Let's consider the output on the right-hand side of the screen. Again, we are drawing 3 squares. Here, the use of nested loop does not help, so we need to do something else. To draw the 3 shapes, you have to write 3 times a very similar piece of code. In fact, if we abstract the specific values, the code is composed of exactly 3 copies of the same sequence of instruction. Clearly, this is code duplication. In addition, the written code is monolithic. That is, it is a self-contained single block of code. Monolithic code are usually huge collections of statements with no modularization, no code reuse. Remember, copy-paste is not code reuse, it is just bad practice. Monolithic program cannot be maintained nor reused easily. Modular code is minimal and loosely coupled. Segment of code only includes the bare minimum of the functionality and structure needed. Fundamentally, the segment of code generally only has a single responsibility. Loosely coupled and tightly coupled code are terms that describe how dependent different parts of a software system are on each other. Loosely coupled code means that the components have minimal dependencies and can function independently, which makes them easier to test, maintain, and reuse. Tightly coupled code means that the components have strong dependencies and cannot function without each other, which makes them harder to test, maintain, and reuse. This directly translates into how easy it is to replace and change them. The aim is to have loosely coupled segments of code, so it is easier to change or reuse them without affecting other segments of the code. The main idea behind modularization is to decompose and separate complex tasks into smaller and more manageable subtasks. Separation of concern is a design principle in software engineering that aims to reduce the complexity and increase the maintainability of a system by dividing it into smaller and more modular components. Each component should have a single responsibility and minimal dependencies on other components. This way, changes in one component will have less impact on the rest of the system, and testing and debugging will be easier. In layman terms, it does only one thing. Semantically coherent is a term used in software engineering to describe the property of a system or a component that has a clear and consistent meaning. Semantically coherent components are easier to understand, maintain, and reuse, as they reduce the complexity and confusion that may arise from inconsistent or unclear semantic. Semantically coherent is probably better explained by an example. In Python, you have a module called math. This module groups together a series of mathematical values such as pi and a series of mathematical functions such as sine and cosine. What you do not have in this module, math, are functions to draw a square or a triangle. It does not make sense to have in the same module something to compute mathematical operation and something to do some graphics. In most cases, if you need to use the mathematical function, it is very unlikely that you need to draw shapes. Drawing shapes should be in its own module. Within the module math, the meaning of the object is consistent. That is, computing simple math function. At our level, we have two tools at our disposal to achieve modularization. Create a module, that is a file containing a segment of code, and define a function. We have seen in a previous video that having similar code in two places have some drawbacks. Failing to keep related part of the code in sync is a common problem in program maintenance. Function can be used to reduce code duplication. Function makes program more understandable, easier to maintain, easier to reuse, as well as facilitating teamwork. To go back to our earlier example of drawing concentric squares, we can define a function to draw a single square of a given size at a given location. First, we need to define the parameters needed to draw the square. We need the position of the top left corner and the size of the square to be drawn. These are given by the parameter x, y, and length. You may have noticed that the body of the function is exactly the sequence of code used in the for loop in our initial implementation of the code. The power of using function is obvious when calling a function to draw the three squares of our output. We need to make three calls, highlighted in yellow in this code. Remember, the interpreter reads a source code from top to bottom, so you must be careful. The definition of the function must be written before any call to the function. Otherwise, a name error is raised and the program crashes. Comparing this code to the initial implementation, the benefits are clear. We declare what the function needs to do only once, and then we call it as many times as required. In our case, 3 times. In addition, if we find a bug in our function, we need to fix it in a single place, in the declaration of the function. The function calls remains unchanged. In short, write once, use many times. Furthermore, the function square we wrote for this program can be reused by another one just by importing the module containing the definition of the square function. There are important points to consider when designing a function. First point to consider is separation of concerns. For example, a function shouldn't deal with taking the input from the user, then processing that input, and finally outputting the result of the process. The function should only do one and only one thing. Either take the input from the user, validate it, and return it, or process the input and return the result of the process. In this case, the input is given via the parameters. Or manage the output. Here the word manage is used to encompass writing the output to a file or on a terminal or on a Windows, or send it to another process. The second point to consider is to determine what parameters are needed, if any, to complete the computation. And the final point to consider is to determine if the function needs to return a value or not. For example, when displaying the output on a terminal or saving to a file, it is unlikely that the function will return a meaningful output. When talking about function, there is another concept that is important to grasp: precondition and postcondition. Frequently, a programmer must communicate precisely what a function accomplishes without any indication of how the function does it. The precondition statement indicates what must be true before the function is called. In other words, the precondition states the situation under which the function operates correctly. The postcondition statement indicates what will be true when the function finishes its work. The postcondition is only guaranteed if the precondition is satisfied. Be very careful. This also means that the function may return an invalid or erroneous result if the precondition is not satisfied. The program may enter an invalid or unsafe state and will need to terminate or simply crash. The programmer who calls the function is responsible for ensuring that the precondition is valid when the function is called. The programmer who implements the function counts on the precondition being valid and ensures that the postcondition is true at the function's end. The advantages of defining the pre- and postcondition is to succinctly describe the behavior of the function, the what, without cluttering up or thinking with the detailed implementation, the how. At a later time, you may refactor a function in a new way, that is, changing the how. But any program using it will still work with no changes needed. Code refactoring is a process of restructuring existing computer code without changing its external behavior. Refactoring is intended to improve non-functional attributes of the software. Advantages include improved code readability and reduced complexity. This can improve source code maintainability and create a more expressive internal architecture or object model to improve extensibility. Now you should have a better understanding of the advantages of modularization and in particular, the use of function. You have seen how to refactor your code by declaring and calling function, resulting in the removal of code duplication. The code is linear and easier to understand. The use of function facilitates code reuse and maintainability. Thank you for watching and see you in the next video.